this free tuition series. Today I'm going to show you on Form 4, Chapter 8, that is called the circular measure. This chapter is a continuation from your Form 3. It's about circular measure. Circular measure is about bulatan. Now, to recap what you have learned over some terminologies that we'll be using. In a circle, the length that's to form the circle is called radius. And if you have a line drawn that passes through the center, where the center is here, where this is the center, this line is called the diameter, whereby the diameter is simply represented is in 2 of r, 2 times of the radius, because there are 2 of them of equal length. Now next, they are going to have something called a segment. A segment, or in BM, is called temberang. Segment would simply be the area over, says I have a line, radius, and connected to here. Segment is this area. This area is called segment, or in BM is called temberang. Tembereng, temberang. A smaller region, or maybe I put it shaded. This region, smaller region, is called segment. Whereas the bigger region, this whole region, a bigger one, going to the center, up to here, this big area, just like pie. This region is called a sector. Maybe I'll put it in the green. This is called a sector. S-E-C-T-O-R. Sector. You replace it with a K or in sector. Sector, bigger pie. A small place is called segment, temberang. The length of which covered by the angle called theta. Theta measured in radian. The angle R in radian. Do not confuse with the length of radius. This is radian, where it takes the value of 180 degree is equivalent to pi. We will talk more about this later, but this this part will be on the introduction. And the length of which covered by this segment, they call the arc. Say the length from here, or maybe I'll make another line. Let's say it's here, radius to here, is span to this length. This is called the arc length, or in BM is called panjang lengkok, lengkokan, L-E-N-G-K-O-K, panjang lengkok. This is the length of an arc length, or length of arc, panjang lengkok. Well, in some cases, you are asked to look for what's the name of this line. There's a name for this line. This is called chord. C-O-R-D, if not mistaken. There are some books they'll talk about it, but this is not too important. But the important part is the segment, sector, the arc length, or panjang lengkok in BM. Once you are clear of these terminologies, then we will be able to go into the essence of this. Now, as what we have seen in first page, we will do it over here, the next page. If you are given a sector of theta r radian, the length is called panjang lengkok symbol S, lengkok kan, the radian R. The relationship between the theta S and R will therefore be S lengkok kan, panjang lengkok, S is equals to R theta in radian. This is the first equation that you should know. Let's talk more about the theta radian. Where theta radian is actually the ratio actually. How do you get this is you get a circle, V, the angle and the radian, whereby the length of lengkok kan is equivalent to the total circumference or the lilitan. This is called the lilitan in BM, which is 2 pi r, is equivalent to the theta radian over the whole circle takes the angle of 2 pi. Then you may able to, you bring it up and then rearrange them. That's how you come across with this equation. Next, that would be the angle conversion. Since we know the pi radian is equivalent to 180 degree, therefore 2 pi radian is equivalent to 360. Depends on how the question is given. If you were to convert, says 30 degrees, therefore equals how many radian? To do that, you make use of the first one. You will know that 180 is equivalent to the pi radian. Therefore, 30 degrees will therefore be equals to 30, copy over, divide 180 times across pi radian. Therefore, you would get pi by 6 radian. Excuse me. So this is how you make the conversion, and vice versa. If you are given radian to convert to angle, then you just need to make use of pi is 180, then radian equals to the angle. Let me give an example. If you are given, let's say, 2.3 radian. If in order to get 2.3 radian, therefore you know that pi is equivalent to 180. So 2.3 will be equal to 2.3 divide pi times 180. And you may 2.3 pi is 22 by 7. You may use this times 180. and well, you should get a quick answer. This is just to show you how to do the conversion. There's a little bit of thinking here. Sometimes the question comes into angle, theta, and minute, where you have one minute, as in your analog clock, is basically equals to 60 seconds. So therefore, if you were to have what, 28 degree 2 minute, then simply you were able to convert it to angle that is about 28 plus 2 over 60. Because every 60 seconds equals to 1 minute. That would be equals to 28 degree 0.033 degree. The same is true if you want to convert it back into radian. So you just make use of the 180 degree equals to pi. So therefore 28.033 degree would be equals to 28.033 over 180 times pi. That would give you the answer to be 0.489 radian. This is a conversion between angle. The next you need to know about the area. First part is on the panjang lengkok. Next would be the area, luas bulatan, luas sector, luas segment. Oh no, sorry, it's not segment. Segment is called the tembereng, luas tembereng segment. Area of a circle. Now, by definition, again we start with a sector. Given angle in radian is always important in radius. This small pi is one part of a circle. You cut it off from a circle, you cut it to here. Now, based on what you have learned in Form 3 in your lower grade last time, area of a circle area is pi r squared. Now over here, you get to learn, not to learn, but it's a further derivative. If you want to get this small area over 360 degree, therefore the area would be simply take the angle over 360. It's just how many parts of 660, and then you times it with pi r squared, where pi r squared is one whole circle. This is 360 degree. This is an angle. Now, if you were to further convert this angle in degree into radian, if you convert degree to radian of the definition that I've used earlier, pi and 180, you get to know that the area of this sector is therefore equals to 1 over 2 theta r squared. Now, you may prove it later, and this is the equation. The proof is rather simple. If you manage to prove it, you may pause this video, try to prove it, because the next part of to prove it to you. The proof. You doesn't need to know how to prove it, but I just let you know that they are related. They are interrelated. Now, given that the area from here, area of a theta and angle is basically, I separate them because I want to convert it. The theta to radian is equivalent to 1 over 360 pi r squared. This is not yet radian. I want to convert this to radian, whereby is equals to theta radian over pi times 180 pi r squared over 360. 2 pi and pi, therefore is 1 over 2 theta, r squared. Now it looks so simple here, but I would recommend that you all to try to prove it. It's a matter of conversion, angle conversion. If you were to have theta angle, and you know that pi is 180 degree equivalent to, so theta will therefore equals to theta over pi times 180. You get the radian. This is kind of like side note for you. You may pause this video, rewind to the previous page on how to get the proof out from here. So this is the second equation, area. Now next would be the area of a triangle. Because what happened, if you examine carefully or you look through those questions later, most of the time you would have a sector, tambourine, a lilitan. What happened is, this is a chord, C-R-D. You form a triangular. This is the R, this is radius, and this is my theta r. This would be an interesting part because you need to find out what's the area. Your question, you need to find out what's the area over here. Now, in order to solve this kind of problem, you need to make use of trigonometry you learn in a lower form. Let me do it over the next page as a side note. No, I'm going to do it here. For any triangular, of angle A, angle B, angle C in degree or radian is not much of interest at the moment. If you need to find out the area of this triangle, there's no way for you at the moment unless you know the perpendicular height h, and you know the base height they call it A. In the lower form, we learn the area is equal to half base times height. This is what we have learned, right? Yes. But now, if you need to find out the triangle, look like this. Given an angle of B. The area now, the equation can be derived from the previous area formula, where therefore the area now is 1 over 2. In order to get this height over here, I know this is a sign C and B. Excuse me. The base height would remain the same, whereas the height length is opposite over adjacent. I would call this as the A times C sine theta. Without radian, maybe this angle. Where this is the H length. This is the H. Right? So, by using the same manner, if you examine carefully, if I want to look for the area, I have the B angle. All I need is A and C. We write this equation, it could be either 1 over 2, A and C, missing B. So meaning, if I want it to be B, C, sine theta, you still get the answer. It's also equals to maybe B, C, A, C, A, B. A, B, sine theta. Okay? Doesn't really matter how it goes. You have B, C, sine theta, A, B, sine theta. You would get the answer of a triangle. By using the same manner, same concept, in order to get the area of this segment, therefore the area of the shaded region will therefore be, the concept wise, I make use of the bigger sector. I find out what's the area of bigger sector. I subtract the triangular of the same R. They have the same R. So area of a segment will therefore be 1 over 2 theta R radian. Must be in radian, is important. R squared. Whereas the area of a triangular, subtract here, is 1 over 2. Have A, B, B, C, those are the side actually. Where here I have R and this is R of angle, theta R. You find that it's equals to 1 over 2 R squared sine theta R. Remember, this is now R. You further simplify this equation, therefore it will be equals to 1 over 2 common R squared theta R subtract sine theta R radian and sine radian. Make sure you have you know how to change the mode of a calculator, angle to radian. I will not be able to show it here because different model it shows different method. So make sure you know how to change the mode of your your calculator from radian to degree and degree to radian, vice versa. So that will be the third equation. This is the third equation that you should know of an area. for an area. And this is the another method in how to get the area of a triangle, besides just using the base and height. The concept here is rather important, because this is a rather important concept. To get a shaded area, you need to sketch it out. The big one subtract with the smaller one, so that you get the shaded region here. In exam, there's no harm to sketch this. To sketch it, then only comes up with an equation and an equation, and then derive this and put in the numbers, then calculate, and you get the answer correctly, then you get full mark for this question. So it's this chapter wouldn't be a really hard chapter. It's a matter of we'll be able to find out the area, the radian, and so on. There are, of course, questions that to look for the parameter. Says next would be the parameter, a short but simple one. Parameter of a sector, perhaps. Say this is a chord. The parameter here and here, given that the angle here is theta, radian, and the length of radius, right? Now, if you were to find out, you need to find out the parameter. First of all, you need to find out the arc. Maybe I put it as a label it. It's easier. Very hard without label. Say this is my O, this is A, this is my B. Okay, my arc length AB is rather simple, because arc AB is straightforward R theta. R theta R. S is R theta. Very straightforward. The chord of AB, the line of AB, would be something more challenging, because what happened here, the chord of AB, this line, is from a triangular A and B. You have R, you have theta R. First of all, in order to get that, you need to agree with the term. If you drop perpendicular line, a bisecting line, simple, same. Let's say maybe this is maybe A, B, C, maybe C. What happened is, you may make use of the trigonometric rule again, whereby your AC length is equivalent to R sine the bisecting, R over 2. It's half a radi. So therefore my AB will be equivalent to 2AC. Therefore my AB will be equals to 2R sine of the angle, half by 2. I don't think you should memorize this, but you just need to know how to get this length. And then you memorize it, no use, because you will forget it. You just understand this concept. Perpendicular line, bisecting line, left and right the same, so you get this length, vertical line. And then you know this length is double of it. So therefore the chord AB would be therefore be equals to 2r sine theta by 2. So the total parameter will therefore be equals to r theta in radian plus 2r sine theta radian over 2. It is really important to make sure that your calculator understands the number you key in is in theta radian. The ability to change the mode from degree to angle is important, especially in this chapter, because otherwise your calculator thought that it's a sine of an angle. Well, I think that's all for now. I hope you grasp the concept of how to get the parameter. You make use of it, visualize it, this and that, list it out here, list it down, get the equation, and you work out the answer. Eventually you get to answer all the question. Now I would really hope that you will go through the questions in your textbooks, in your exercise text, workbook, at least 30 questions to 40 questions. You need for about a week or two to get this chapter out, done. And then you will find that this chapter is basically another chapter that you should do, another question that you should do during your SPM. It's like a bonus question. Circular measure. I hope you like my video. Do share my video over social network site. Share with friends. It helps others. That's the main purpose of this video being made, is to help people. And it's also to help you. Like my channel. Subscribe to it so that you get updates of my next following video. And most of all, watching this video doesn't guarantee you anything without your own effort in trying out those questions. You need to practice. Looking at it is simple, but when you do it yourself, you will find the difference. It's really hard to do it. You need to practice. You may watch my video over and over, but without practice, you will not be able to excel in this chapter. Well, that's all for now. Thank you, and have a nice day. Bye bye.